What is up, YouTube, and welcome to another video. In a previous video, we've taken a look at how to get a Kubernetes cluster running in Microsoft Azure. If you haven't seen that video, take a look at the link down below. I take you through all the steps of everything you need to know of how to get a Kubernetes cluster up and running in Azure. Today, we're going to be taking a look at the same thing, but how to do it all in Terraform. So without further ado, let's go. So the first thing you're going to need is an Azure account. So what you want to do, go over to Google, type free Azure account, just scroll down, look for the create your free account today link. Once you're in that link, this will give you access to 12 months of free services and everything you're going to need for this video. If you already have an Azure subscription, in the next step, I'm going to show you how to interact with that subscription. Now, if we head over to the Terraform documentation, you can see they have an Azure provider. And this is basically a module that allows us to interact with Microsoft Azure and spin up our infrastructure in the cloud. Now, Terraform is great because rather than using bash scripts or PowerShell scripts and creating our infrastructure line by line or script by script, we can just create a Terraform file and let Terraform do all the work. And that becomes our source of truth and our infrastructure as code. Now to do that, we're going to need to authenticate with Azure. So there's a couple of ways to do that. If you're running locally and you're the one running Terraform all the time and interacting with Terraform, they recommend to use the Azure CLI. So it'll just use your credential. But if you're running it in a CI/CD manner, like in Jenkins or somewhere in the cloud, you're going to want to use a managed identity or a service principal to do the work for you. So in this video, I'm going to be using a service principal and I'm going to give it the permissions it needs to interact and manage our infrastructure. So if you're new to this channel, everything I do on this channel is on GitHub. If you clone the source code, you see the Docker development YouTube series. And if you go down, we have a Kubernetes folder and we have a cloud folder. So all my Kubernetes in the cloud series is all in here. I have Amazon, Azure, DigitalOcean, Google, and Linode. Today we're going to be looking at Azure. And for this example, I've created a Terraform folder with a README inside it. So everything I do is documented in here so you can follow along. So the first thing we're going to need to do is get the Azure CLI. So if we go over to Docker Hub and we search for the Azure CLI, we can see we have the CLI tools here to interact with Microsoft Azure. So the first thing we're going to need to do is gather some information. So the steps we can follow here is to run the Azure CLI in a Docker container. This is the easiest way to get the CLI up and running without having to install the dependency. So what we do is we say Docker run interactively. We mount the entire Git repo into the container, into a folder called /work, and then we set an entry point to run some bash, and we're just going to run 2.6.0 of the Azure CLI. Then what we're going to need to do is gather some information about our subscription that we can pass to Terraform. So to do that, we're going to need to run AZ login. So what you're going to want to do now is copy this URL and open it into the browser and then just follow the prompts. You're also going to need to paste this code into the browser when it prompts you, and then give it your account details. Now, once you've logged in, you'll see that there's a tenant ID. You're going to want to grab that entire tenant ID and create an environment variable called tenant_ID. That allows us to use the parameters much easier. So then the next thing we're going to want to do is list out the subscriptions that we have access to. So I'm going to say AZ account list, and I'm going to list out our subscription because we're going to need the subscription ID. And to grab that, you can see here, I'm also going to create an environment variable, and I'm going to grab the subscription ID and I'm going to pass it into the environment variable called subscription. And then just to make sure that any commands I runs against the subscription, I can run the AZ account set command and pass the subscription ID. That'll make sure that every command I run will run against that subscription, so I don't accidentally do anything to my production subscription. Now, in order to interact with Azure using Terraform or the CLI, we're going to need a service principal. A service principal is just a service account that we can use to interact with our Azure infrastructure. So all the steps you're going to need is all documented in here. So the first thing we're going to do is create the service principal using the AZ_AD_SB create for RBAC command. We're going to give it a name called AKS getting started -SB, and I'm going to output the result of the creation as JSON. So to view that service principal information information, I'm just going to echo out that environment variable, and we're going to need two pieces of information here: the app ID, which is the service principal ID, and the secret, which is the password over here. So we need to keep the app ID and password for later use. The next command we're going to need to run is we're going to create a separate environment variable to hold the app ID. So I'm going to say service principal equals, and I'm just going to echo out that JSON and grab the app ID that we have at the top here. I'm then going to do the same for the secret. I'm going to say service principal secret equals, and I'm just going to echo out the JSON and grab the password field over here. Now currently the service principal that we created has no permission, so we need to give it contributor permissions to the infrastructure that we want Terraform to manage. So to do that, it's very simple. I'm going to run the AZ role assignment create command. I'm going to pass the service principal ID, and I'm going to give it scope over my subscription. I'm going to give it contributor rights. This will allow Terraform to manage infrastructure on this subscription. And service principal also allows you to give more granular details, so you can give contributor over a specific resource group or whatever infrastructure you want Terraform to manage. So now that we have a service principal, the next thing we need to do is go and grab the Terraform CLI. So to do that, I'm just going to run curl, and I'm going to grab the Terraform 0.12.28 binary. So I'm going to go ahead and download that. And then I'm going to also run the unzip command to extract it. So I'm going to unzip that, and I'm going to give it execution rights, and I'm going to move it to user bin. That means I can now have access to the Terraform command. So what I'm going to do is I'm going to change path, and I'm going to change path into the Kubernetes Cloud Azure Terraform folder. And you can see now we have an empty folder here. There's nothing in here. So how do we start spinning up our AKS cluster in Azure? The first thing we're going to need to do is write a Terraform file, and we're going to have to import the Azure RM module and then authenticate with Azure. So the first thing I'm going to do is I'm going to create a main.tf file in this Terraform folder. So if you do ls, you can see I just created a main.tf. And the other thing I'm also going to do is create a variables.tf. So this will allow me to pass information to my Terraform file. So what I'm going to do is I'm going to install the Azure provider. So I'm going to say provider Azure RM. I'm going to import version 2.5.0, and I'm going to pass a bunch of things to authenticate with Azure using Terraform. So you can see I have a variable called subscription ID telling us what subscription we want to access. I have a service principal ID and key. That's the service principal account we just created, and an Azure tenant ID. Now, if I go over to the variable section, we have to actually declare these variables here. So that's very simple. We just use the variable block and we give it names. So you can see the names I have over here: service principal ID, key, tenant ID, and subscription ID, and they match the ones over here. So that's how you pass information from Terraform into your main file. Now, to test whether this works, we're going to need to run the Terraform init command, and what this will do is initialize our file. It'll download any modules and providers that we refer to. So you can see here it says checking provider plugins. It's going to go ahead and download the Azure RM plugin for 2.5.0, and it'll initialize Terraform. So we're pretty much good to go. It's also going to store all of this initialization files in a .terraform folder. You can see it's downloaded all the plugins over here. So one of the cool things about Terraform is it has a plan function, which basically shows you the execution plan of what Terraform is about to do. So you can run this command when you've made any changes, and Terraform will tell you exactly what updates it's going to apply, if any. So what we're going to do is we're going to test this out by running Terraform plan, and then we use the -var argument to pass in environment variables. Now we have to pass in all those variables we've defined, and this helps us keep secret information out of Git. So we can say service principal ID, pass that in. We can say service principal key, pass that in, tenant ID, and the subscription. So if I go ahead and run this, we can see that everything is all good. Terraform keeps an in-memory state of the plan, and it keeps this inside of a Terraform state file. So you can see here there's no changes, infrastructure is up to date because there's no actions that we gave it to perform. Now, Terraform has the concept of modules. Modules are a great way for stitching together multiple Terraform files, which keeps your main Terraform file simple and easy to read and understand. So what we want to do is we want to create modules. We don't want to literally put everything into the same file because it'll make it really hard to read and digest. So in my Terraform folder, I'm going to create a new folder called modules, and I'm going to create a separate module for spinning up Azure Kubernetes. So I'm going to create a new folder inside here called cluster. And you can create any kind of module folder structure that you want that makes sense to you. So I'm going to create a new module called cluster, and inside here I'm going to create a cluster.tf file. So this will represent our Azure Kubernetes infrastructure. Now for this module, we're also going to need to specify some variables. So I'm going to create a variables.tf file because we're going to want to pass variables from our main file into our child module. Now because Azure Kubernetes is going to need a service principal in order to spin up things like load balancers and storage and things like that, we're going to need to create our first variable in the cluster.tf folder in the file called service principal ID and service principal key, because we know AKS needs a service principal in order to function. So now we can start populating our cluster file. Now we're going to need two things in the cluster file. The first thing we're going to need is a resource group. We need to create a resource group to put our Azure Kubernetes service inside. So to do that, I'm just going to create a new resource inside of our cluster.tf file called Azure RM resource group. And I'm going to give it a name called AKS getting started. So the name of my resource group is going to be AKS getting started. And we're going to deploy this to a location from the variable, our variable called location. So we need to define that variable. So if we go over to the variables file, we need to specify a location variable. So I'm going to just put a location here, and I'm going to get a default value of Australia East. I've referred to the Azure RM resource group resource. Now there's a bunch of resources. If you go over to the Azure provider on the HashiCorp documentation and you scroll down, there's all these different resources you can apply. These literally represent all the resources available in Microsoft Azure. So today specifically, we're going to look at container resources, and we're going to take a look at the Azure RM Kubernetes cluster resource. This is everything to do with how to provision an AKS cluster using Terraform. So now if we go back to our cluster.tf file, we can see now we've told Azure to create a resource group. So the next thing we're going to need to do is we're going to need to tell it we want to create a Kubernetes cluster. So to do that, I'm going to create another resource in here. It's going to be the Azure RM Kubernetes cluster, and I'm going to call it AKS getting started. I'm going to give my cluster a name, and I'm going to give it a location as well. And I'm going to use the location of the resource group. So you can see Terraform gives us the ability to stitch up variables between different resources. So here I'm saying I want to use the resource group called AKS getting started, and I want to use its location and its name. I also specify the resource group I want the cluster to go in, and then I give it a DNS name, and I also provide Kubernetes version from a variable. So we're going to have to go back to our variables file for this cluster, and we need to pass in a new variable for the Kubernetes version, and I'm just going to run 1.16.10. Now with Azure Kubernetes, we have to provide a default node pool. So to do that, inside of this resource, I'm going to add a default node pool block. I'm just going to give it a name called default, and we're going to have one node. This is the VM size we're going to use, and we're going to use VM scale sets as the type for this node pool. And I'm also going to say I want 250 gigabytes of disk. All the fields that you see here are basically the same fields I used in my introduction to AKS video guide using the Azure CLI. So Terraform has its own module where we can pipe in all these different fields, and we can basically do things like create multiple node pools. We can provide VNet IDs if we want to integrate our cluster into an existing VNet, and a bunch of other cool things. So the next thing I'm going to need to do is provide a service principal that AKS can use in order to function. So I'm just going to create a service principal block, and I'm going to create a client ID and a client secret, and I'm going to pass in the variables that we have defined already: service principal ID, service principal key. And if we go to the variables, we can see those two are over there ready to go. The next bit I'm going to need to do is provide a Linux profile. Because our default node pool is going to be Linux, I need to provide a username and an SSH key for these machines so that we can use SSH to access them in case we want to. So to do that, I pass in a Linux profile. I'm going to give it an admin username called Azure user, and I'm going to give it an SSH key, again, from an environment variable. So we're going to go through and go back to the variables, and we need to define a variable for our SSH key. I'm going to just paste that over there. Then I also want to create a network profile. So below the Linux profile, I'm going to create a network profile, and this will tell AKS what network plugins to use. So I'm just going to use the default kubenet, and I'm going to use a standard load balancer. Now the next block I'm going to add is just a bunch of add-ons in the add-on profile that I want to disable. The ACI connector, I want to disable that. I want to disable Azure policy, disable all these features such as the dashboard and the OMS agent. Now if I go back to the Terraform documentation, you can see that they have Azure RM Kubernetes cluster. That is as the resource block we've just defined. And if you go through here, they have a ton of information. They have the add-on profile that I used, DNS prefix, default node pool, all the stuff I've just shown you. But there are a lot of extra things here. If you want to play around, I'm going to leave this document up to you. You can add auto scalers. You can do a whole bunch of things like drop your cluster into an existing VNet and a bunch of other cool things. So now that our Terraform files are ready and our modules are ready, we missed out one crucial part, and that's the SSH key. You can either bring your own SSH key or you can generate one like this. So I'm just going to say SSH key gen. I'm going to pass in a very super strong secret email address, and I'm going to create that in that directory. And then I'm going to cat out and pass the public key into an environment variable called SSH key. This will give us the SSH key that we're going to pass through to Terraform. Terraform will then pass that to AKS, and we can use that to access our machines running on Kubernetes if we need to troubleshoot stuff. So now if we go to our cluster module and we go to the variables, we've added a bunch of extra variables. Now we've added location, Kubernetes version, and SSH key. We need to make sure that we define these variables on the outer file, on our main Terraform files variables as well. So what I'm going to do is I'm going to go ahead and paste the extra information bits that we need, the SSH key, the location of the Kubernetes cluster, and the Kubernetes version. Because what we need to do in our main variables, we need to be able to pass it through to our child module. Now before we run the Terraform apply command, we want to see what Terraform is going to do when we run Terraform apply. So we use the Terraform plan command and we pass in all the variables I've just mentioned. Now when we run this, we see that there's no changes. So why is that? That is because if we go back to our main Terraform file, all we're doing is just pulling in the provider template. We need to actually go and execute our child module, which we haven't done yet. So to do that, we need to create a module block in this main Terraform file. So I add a module called cluster. That cluster represents the module over here called cluster, and we pull in its source. So you can see I'm pulling it from the modules folder, from the cluster folder. So Terraform will know where to find that cluster.tf file. I then pass in the variables for that module. So we've defined in the variables over here, we've defined service principal ID, key, SSH key, location, and Kubernetes version. We then also defined it on the outer template in this main TF variables over here. So we go ahead and pass that down to that module. Now to make sure that the Terraform is able to pull in our new modules, we have to say Terraform init, and that's going to go ahead and initialize all the plugins and modules and things it needs. And then we can go ahead and run the Terraform plan command to see what it's going to do. So now it says Terraform will perform the following actions. You can see that it's going to create our resource group, it's going to create our cluster, and down below it's going to give us a summary. So it's going to say 2 plans to add, nothing to change, nothing to destroy. So basically the 2 resources that it's planning to add is going to be in the cluster TF. It's basically going to be these 2 resources, the resource group as well as the AKS cluster. So now that we know what Terraform is going to do, we can go ahead and run the Terraform apply command with the same variables that we passed in before. And if we do that, Terraform will tell us again that it's planning to add 2 resources, and it's going to ask us for confirmation. I'm just going to say yes. And now it's going to go over and start creating our resource group and creating our Kubernetes cluster. So this will take a couple of minutes to come back. Right, now you can see Terraform has gone ahead and applied the resources, so it's complete. If we take a look at the Azure portal, we can go to our resource group and we see we have a cluster up and running called AKS getting started. It's been created. It has 1 node pool and it's running Kubernetes 1.16. Now, one of the strengths about Terraform is when we want to make changes to our Kubernetes cluster, Terraform is really good. Now, normally what happens in traditional infrastructures, people run PowerShell or Bash scripts against their cluster, and they don't have a source of truth of the state of the Kubernetes cluster or the infrastructure running in the cloud. And this is one of the strengths of Terraform, is the Terraform files and modules become your source of truth. If you want to make changes, you can change the files and just reapply. So what if we wanted to make changes to the cluster? Now, one cool thing I'm going to show you here is that we can go to our cluster resource. We see we have our Kubernetes cluster here. We can add another resource here called Azure RM Kubernetes Cluster Node Pool. So let's say we want to monitor our cluster and we want a separate node pool for running all our monitor stuff. So I'm going to create a node pool called monitoring. I'm going to give it a name. I'm going to point it to the same cluster ID of the cluster we created up here. So I'm going to say Azure RM Kubernetes Cluster AKS getting started ID, pass that ID in. And this time I'm going to create a different VM size. I'm going to add 1 node account with 250 gigs of space, and I'm going to provide an OS type of Linux. And if we now run Terraform plan command, we'll be able to see what Terraform is going to do. Terraform will now look at the cluster state, look at its state file, and determine the changes. So you can see here it came back and said one plan to add, nothing to change or destroy. So Terraform knows to go and add that node pool. I can make a couple of extra changes, like I can change some of the parameters over here. Let's increase the count of our default node pool to 2. So let's scale up our cluster as well as add a node pool to it. So to apply these changes, rather than running PowerShell or Bash scripts, I can now just make the changes to the file and say Terraform apply. So now Terraform will detect the changes and it will go ahead and ask us confirmation if it can apply the files, and we're going to just say yes, and it's going to go ahead and apply it. So now while Terraform is busy, let's go ahead and look and see what it's doing. So we go to our resource group, go to our Kubernetes AKS cluster. We can see now we have 2 node pools. So the operations are succeeding. We have a default node pool being scaled to 2. So we increased it to 2. That's one thing we asked Terraform to do. The other thing is create our monitoring node pool. So it's going ahead and it's creating that node pool. Now, for those of you who have worked on Kubernetes before, you would know that creating a cluster is not where it stops. We normally have to go and provision all the infrastructure on top of our Kubernetes that we need to make our Kubernetes cluster operational. These things can be ingress controllers, they can be monitoring things like Prometheus, they can be logging services like Loki, Grafana, and Fluentd. Now, instead of having to go and access our cluster and then applying a bunch of YAML files to the cluster, Terraform has a Kubernetes provider, so it's able to do all of this stuff for us as well. This is one of the really neat selling points of using Terraform to spin up infrastructure like Kubernetes. So in order to do that, now I'm going to show you how to spin up a deployment with 2 pods and a load balancer. Now in order to do that, we're going to create another module. So in this modules folder, I'm going to create a new module called K8s, and I'm going to create a new Terraform file called k8s.tf. Now you can create modules for monitoring, ingress controllers, logging services, service meshes, whatever you want to apply. I'm just going to show you the fundamentals and then you can take it from there. So in here, I'm going to create a new Terraform file, and I'm going to use the Kubernetes provider. Now, if we go to the Terraform documentation, the Kubernetes provider is listed here, and it has a bunch of examples you can follow. So you can see we can do a bunch of things like config maps, daemon set, deployment, pods, services, ingresses. So all the YAML files that you have, you can convert them to Terraform files and then let Terraform do all the work for you. So what we're going to do is we're going to create our first file, and we're going to call it the Kubernetes provider, and this needs authentication details. So how do we want Terraform to authenticate with Kubernetes? So there's a few ways to do that, but the easiest way is to tell it not to load a config file, and we're going to pass the host of the API server of AKS. We're going to give it the client certificate and the client key and the cluster CA certificate of AKS. Now, as we know, we're getting these from variables. So what I'm going to do is I'm going to create a new file in this K8s folder, and I'm going to call it variables.tf. And then in that file, we're going to have to paste those variables. Now, these are the variables that Terraform will use to access the AKS cluster and deploy our deployment with pods and services. So we define that over there, and then let's build out what we want to deploy. So I've just grabbed an example of a deployment. So this is what a deployment looks like. So we pass in a resource called Kubernetes deployment, and I'm going to call it example. And then this is pretty much the same thing as similar to the JSON and the YAML that you would pass to kubectl apply or your Helm chart. But here we have a deployment spec. So I'm going to create 3 replicas. I'm going to create some labels and selectors, and then I'm going to pass in the image I want to deploy. So I'm just going to run nginx as this example. I'm going to give it some resource limits. I'm going to give it a liveliness probe. So that is what a basic Kubernetes deployment would look like in Terraform. Now, what I also want to do is I want to expose this deployment through a Kubernetes service. So I'm going to create another resource here called Kubernetes service. I'm going to call it example app, and I'm going to name it Terraform example. Over here, I'm just going to select my deployment that I created above, and I'm going to expose port 80, and I'm going to do so via a load balancer. Now, once we've created this module, we have to go and stitch it up to our main.tf file. So if we go over to our main Terraform file, at the moment, we only have Azure authentication, and we have our Kubernetes cluster that we want to create. We now also have to tell Terraform that we want to deploy some stuff to that AKS cluster. So I'm going to add another module reference here to our main file, and I'm going to call it K8s, and it's going to source it from this modules directory, from this K8s folder that we just created, and I'm going to pass it the variables that we need. And this is one of the key strengths of Terraform, is that we can stitch up these things using variables and using variable outputs. So take a close look over here. We have host, client certificate, client key, and cluster CA certificates. These are variables that we defined in our K8s module. Now, in order to get that, we need to grab those from output of our cluster module. Now, we haven't defined those outputs yet. So part of the Azure providers AKS module, it has a bunch of output variables. So if we take a look at the Terraform documentation, we have the Azure RM Kubernetes cluster. If we scroll all the way down, we will see the attributes reference page of showing us what attributes are exported. So whenever Terraform creates resources, it has the capability to export output. So what we can do is we can actually output the kubeconfig file as part of that module. So to do that, we need to go to our cluster folder and we need to create a new file called outputs.tf. So this output file will define whatever variables we want to output as part of the cluster creation. So the first thing we're going to do is create an output block called kubeconfig, and we're going to output the value of the Azure RM Kubernetes cluster. This is our cluster that we created, and we're going to output the kubeconfig raw. That is the same value that's been defined in the documentation over here. And then we're going to use this value in a couple of more output variables. You can see I'm referring to them here by saying Azure RM Kubernetes cluster, AKS getting started, kubeconfig 0, and I'm pulling out the cluster CA certificate, the client certificate, the client key, and the host. And I'm pulling those out as different output variables. And now we can go ahead and use these output variables from our cluster module, and we can input them into our K8s module. So this will allow our Kubernetes module to authenticate with the Azure AKS cluster and deploy our deployment to pods and a server. Now, because I've added new modules, I have to rerun the Terraform init command. So this will go ahead and download now the Kubernetes plugin as well. And then to see what changes we're about to make, we can run the Terraform plan command. And now we can see that there are 2 plans to add. So those plans are basically defined in the K8s TF file. We have our Kubernetes deployment, which is one plan, and if we scroll down, we have a Kubernetes service, which is the other plan. So Terraform exactly knows what to go and change in our infrastructure. Now, to make things a little bit more interesting, what I'm going to do is I'm going to go to my cluster TF and I'm going to remove this node pool. So let's say I decided I no longer need this node pool for monitoring. I'm going to go ahead and delete that. I'm also going to scroll up to my default node pool and say I no longer need 2 instances. I'm going to scale it back down to 1, and then I'm going to rerun the Terraform plan command and see what it tells me now. Now this shows you the power of Terraform. So now we can see we have 2 plans to add. That's our deployment and our Kubernetes service. And then we have 1 plan to change. That's our default node pool on our AKS that we're planning to scale down. And we have another plan to destroy, which is our monitoring node pool. Now to apply that, I'm just going to say Terraform apply, and that's going to take a couple of minutes to execute. So now that that's done, let's see what we've deployed. So I'm going to go ahead and grab my Kubernetes config saying AZ AKS get credentials. I'm going to pass in the name of my cluster and the resource group. That's going to go ahead and grab the config, download it, and ready for kubectl. So what I want to do now is go ahead and download kubectl just using the curl command, and I'm just going to give it execution rights, and I'm going to move it to user local bin. And now let's take a look at what we've deployed. I can say kubectl get service, and we have a service exposed via a load balancer over this IP, and I also have a deployment called Terraform example with 3 Nginx pods busy creating. And if we go over to that IP address in the browser, we can see we've deployed our Nginx server. So this showcases how easy it is to get infrastructure up and running and manage your AKS cluster and all your fundamental services that run on top of that using Terraform. So hopefully this video helps you guys get started with Terraform and AKS. Let me know down in the comments how you guys manage your infrastructure, and especially around Kubernetes. And also let me know down below what sort of videos you'd like me to cover in the future. And as always, like and subscribe, and until next time, peace.